In this problem, you given three cylinders and each rotate independently about a common axis. Two of the cylinders rotate in the same direction and the other rotates in the opposite direction. We need to find out what is the total angular momentum of the system. So let me explain the problem first. Let's say you have one cylinder and you have another cylinder. This is your third cylinder. And this is the rotation of the axis. Let's say this rotate along this direction. We call the anti-clockwise, and let's say this rotate in the clockwise rotation, and all rotate about the same axis. So the moment of inertia of each cylinder, and these three cylinders rotate independently. It's not connected together, but it's about the same common axis. So let's find it out, the moment of inertia of each cylinder. We know the moment of inertia moment of inertia of the cylinder is equal to half m. This is for the solid cylinder. This is for the solid cylinder, not the hollow one. What is, let's put all the numbers here. Half, the mass is given. What is the mass? It says the mass here, this is the given information. The mass is 65 kilogram. The mass is given 65 kilogram. Radius is given 1.47 meter. Okay. So this cylinder, let's say omega 1. I'm just calling omega 1. This is omega 1, and this is omega 2. The omega 1 is 3.83, and the omega 2, this one is given 3.42 radian per second, radian per second. This is all the information given here. Now let's find out the moment of inertia of its cylinder. What's the mass? Mass is 65. And the radius is 1.47. So just need to plug in the numbers. Once you plug the numbers, the answer you will get is 70.2 kilogram meter squared. This is the moment of inertia of each cylinder. Now we need to find out the total angular momentum. Total angular momentum. Total angular momentum. The total angular momentum is equal to I times omega. Okay, so the total momentum is equal to just I omega. Just remember this one in mind. So we have three cylinders, and these two are rotating in one direction, and this is rotating in opposite direction. So the total angular momentum is denoted by L. So what is the net angular momentum? The 2I1, I omega 1 minus I omega 2. I is same because the moment of inertia is same. but the two is rotating with one angular speed and the other is rotating with the different angular speeds, and this is opposite, so that's I just put the negative sign here. Okay, this is negative sign here. To what is the moment of inertia? 70.2. What is the angular speed? Omega 1, 3.83. 3.83. Again, I is 70.2. 70.2, and the omega 2 is 3.42. Just plug in all the numbers here. Once you plug in the total angular momentum, you will get is 298 kilogram meter square radian per second. This is